Morning, students. It's dark outside. Early morning. Here to finish up my series of videos on Match My Line, your take-home test, which I hope you will learn about slope, y-intercept, the equations of lines, and really put all these concepts together and do well and learn the concepts. So here we go. We're going to do a deep dive into challenge number 2, which is really the second question in the test. And for this, you really need to know and understand slope. You need to know and understand slope. That's what this whole thing is about. So slope is the steepness and the direction of a line. The steepness and the direction of a line. So I'm going to share my screen here. Give me a second to get set up. All right, here we go. Steepness and the direction of a line. And I'm going to show you 2 different ways to figure this out, to calculate slope. Got my pen. Steepness, right? That's a measure of how vertical a line is, how close it is to the y-axis. So this, for instance, is a line that is pretty steep. That's a really steep line. It's really close to the y-axis. And direction. So this line has a positive slope. So it is rising as you move from left to right. A line that looks like this is falling as you move from left to right, and it will have a negative slope. Okay. So this is a positive slope, which means it's rising or going up as you look from left to right. And you want to, it's almost like a book, right? You're reading it from left to right. And as this lines go up, as their y values increase, as the x values increase, that is a positive slope. And as you look at a line from left to right, if it is falling or going down, this is falling or going down, you know the slope will be negative. Okay? Some basics about a line. So when we say steepness, we mean how close that line is to the y-axis. And when we say direction, we're saying, hey, is it rising with a positive slope as you look at it going from left to right? Or is it going down or falling as you look at it going from left to right? In which case it will have a negative slope. And so the direction is going down. Okay, so that's what slope is. Now there's 2 ways to figure out the slope of a line. And I will do a couple of examples. So first we're going to look at line number 1. And that's going to be this point number 1 right here. And I'm just going to draw a line. Remember, it says plot 6 lines. Each line should pass through the origin. And one of the 6 points. 1 is done for you. That's what the directions are. So the origin is right here, 0, 0. And so you know your line has to go, line number 1 has to go through that top point, and it also has to go through the origin. I'm going to use blue as the color here. But oops. Your line needs to look just like this. Go through the origin, go through that point, So line number one, we've got to figure out the equation of it. And because it's going through the origin, we do not have to worry about the y-intercept. We just have to figure out the slope. So we know it's going to be y equals m times x. And all we have to do is figure out what m is, because little m is your slope. So the first way I'm going to show you how to do this is to use the triangles method. This is really teaches you the basics of what steepness is and slope. So think of slope. You've got your origin, you've got this point here. Think of slope as a fraction, right? That is the vertical change divided by the horizontal change. So m is a fraction, and it's the vertical change divided by horizontal change. Another way of saying this is rise over run. Your numerator is always going to represent the vertical, and your denominator is always going to represent the horizontal going left to right. And if you look at the blue line, you look at 2 points on the line, the origin and the first point up here, and you can literally count 1, 2, 3, 4, 5 full squares vertical. And if you look at the horizontal change, you can count 1, 2, 3 units horizontal. So your slope is just the ratio of the vertical change, that's 5 units, versus the horizontal change between 2 points on a line. And there is your slope right there. So m, little m, equals 5/3. Done. So you take this 5/3 and you substitute it in for m, and you're good. Now, this is what it looks like when you enter it into Desmos. Let's erase all this. Let's check our work and see if it works. So you're going to enter, you have to use the full equation of the line. So you go y equals 5/3 x. Get rid of that m. And I'm going to erase that line so you can see everything. Now, click check my work. It should draw a line for me. For some reason, it's not. Okay, let's try this again. Reset. Come on, Desmos. Y equals 5/3. Oops, can't forget the x. Check my work. There, that red line just showed up. It went through the origin, it went through that first point, and I know I have completed my mission and task, and that slope works. So that's one way of calculating slope, which is find 2 points on a line, right? Find 2 points where the line intersects the grid lines behind it. Construct a right triangle to show the vertical and horizontal change between the points. Step 2, count the grid squares and write the slope as the ratio of vertical change divided by horizontal change. Simplify your answer. And basically, if you get something like, oh, it's 10 squares over 5, you would simplify that to 2. All right, so that's one way to calculate slope. And I should note, if you're using these grid squares, the triangles as a way to calculate slope, when you get negative slopes, whenever you count down and whenever you count to the left, your slope becomes negative. That's really something that I don't have it in this note, but if, for instance, you're going to do this line, this would be line number 6, and you were going to use this method, the triangles method of counting squares to calculate slope. So you're going to try and figure out the slope of this line. I need that line to go through the origin. So let me do it a little bit better like that. If you're trying to figure out the slope of that line, when you're counting the vertical, so it's 1, 2, 3, 4, 5, 6. You're 6 going down. You have to make that 6 negative, because you can see that this slope, this line, is going down. It is falling as you read it from left to right or look at it from left to right. So it's going to have a negative slope. So anytime you're counting down, it's negative, right? If you're counting up, it's positive. Okay. All right. Now, second way for you to calculate slope is to use the slope formula. And here, write the coordinates of 2 points where the line intersects the grid lines behind it. Use the slope formula. That's step 2. The y coordinate of point 2 minus the y coordinate of point 1 divided by the x coordinate of point 2 minus the x coordinate of point 1. Simplify your answer. And remember, the big note here, the reason why you have these little 2, the little 1, the little 2, little 1, is to make sure you keep the same order for the subtraction in the numerator and the denominator. And you have to keep track of negative numbers in your slope. You have to keep track of the order. Very, very important when you're doing this. So I will do one more example for you guys. And I'll actually do line number 6. If you're watching this video all the way through, you're going to get 2 answers, and you only have to do 3 more, just as a gift from Mr. Chang. Okay. We'll go down here and do this line, line 5. So for line 5, I'm going to use this formula. And I need first, I need to write the coordinates of 2 points where the lines intersect the grid lines behind it. So one of my points is definitely the origin. And I know the origin is 0, 0. And then one of my points, so I'm going to use this point right here, that is 3, -4. Okay, so now I have 2 points. I'm done with step 1. Step 2 is to use the formula. The y coordinate of point 2 minus the y coordinate of point 1 divided by the x coordinate of point 2 divided by, or minus the x coordinate of point 1. So now I need to go look at my points, and I need to decide which point is going to be point 1 and which point is going to be point 2. It doesn't matter what you pick. All that matters is that you keep the order of your subtraction consistent between the numerator and the denominator. So I'm going to make 0, 0, 0.1. And I'm going to make 3, -4, 0.2. And that means the number 3 is the x-coordinate of point 2, and -4 is the y-coordinate of point 2. That's what these little subscript numbers mean. And then 0 is the x-coordinate of point 1, and y is the, 0 is the y-coordinate of point 1. See, it's confusing. Like, that's why you should label every single one of these points so you can use this formula easily. So I need the y-coordinate of point 2 minus the y-coordinate of point 1. So the y-coordinate of point 2 is -4. So I'm going to go -4. And I'm going to subtract from it the y-coordinate of point 1, which is 0. So I have -4 minus 0. That is my numerator. That represents, when you're subtracting these two y-coordinates, that gives you the vertical distance, right? So it's 4 squares. I can just count it. -4 minus 0 is a distance of 4, but it's going down, so it's a -4. So that is essentially your vertical change, just like we saw in the method for using the triangles. Now I'm going to take my x-coordinate of point 2. I'm going to subtract my x-coordinate from point 1. That is 3 minus 0. And my slope is -4 thirds. Oh, come on, pen. It's an ugly 3. That's 3 is my denominator. -4 is my numerator. And so I know the equation of this line is y equals -4 thirds x. So let's see if that works. Once again, the beautiful thing about this is that you can check your work. Y equals -4 thirds. You can't forget the x. Absolutely necessary. I got something in my eye. All right, better. Check my work. There we go. Looks like it. Clear all this. There. My line 5 goes through the origin, through the point at 3, -4. Good. So there you go. Slope, people. Forgive my eye for watering. Got something in my eye still. All right, I'm a pirate. There you go. A primer on slope. Again, feel free to come to office hours. If you have questions about this, good luck.